Welcome to Atlas Narrator. Today we're diving into the world of lost writing systems and forgotten codes. What happens when history hands us puzzles where the script is unknown and the language itself is silent? In this journey, you'll hear about one of the great triumphs of cryptanalysis and about a century-old mystery that might, in fact, be antiquity's most elaborate hoax. Our story begins on Crete in 1908, when Italian archaeologist Luigi Pernia uncovered what we now call the Phaistos Disc. It's usually linked to the Minoan world and is generally treated as authentic, dating to the early 2nd millennium BCE. For decades, the working assumption was simple: the disc carries a text in a natural language, probably written with a syllabic script. Modern analysis has thrown cold water on that assumption. When scholars compare the statistics of side A and side B, they find unusual patterns, features not typical of known syllabic texts. That alone suggests we may not be looking at ordinary language. And there's something else. Some of the signs seem to form deliberate geometric arrangements on the surface. Were those shapes a happy accident of writing, or were they created on purpose? Consider one striking example on side A. The shield sign catalogued as sign number 12 marks the vertices of a near-regular heptagon. To test whether that shape could have happened by chance, researchers built a probabilistic model and ran Monte Carlo simulations. Side A has exactly 49 imprinted signs. 7 positions are occupied by the shield. Under random placement, the chance that those 7 spots would line up to trace such a clean heptagon at the edge of the disc is tiny less than 1 in a billion. In a long run of 10 billion iterations, the pattern showed up just 4 times. If that's true, then the disc might be less a piece of utilitarian writing and more a carefully staged enigma. There's more detail worth noting about that heptagon claim. On side A, there are 49 signs in total, and precisely 7 are the shield sign. In the simulations, those 7 positions were allowed to vary freely around the perimeter. Only in vanishingly rare draws did they fall into locations that trace a near-regular 7-sided figure. In a long run of 10 billion trials, the pattern appeared just 4 times. That is exactly what you would expect if a human intentionally placed the shields to create a shape, rather than leaving them to chance. One expert, J. Eisenberg, has argued that the signs were arranged to create eye-catching patterns, perhaps even that the whole object could be a modern forgery designed to look extraordinary and ancient. That is a minority view, and the debate remains open, but the larger lesson is clear. Sometimes an object we treat as text refuses to behave like one, and the safest conclusion is that the inscription may not have been intended as ordinary language at all. Whether or not the Phaistos Disc is what it claims to be, the ancient Aegean gave us another very different challenge: Linear B. When scholars first tackled it, there was no bilingual key, no Rosetta Stone, no glossary of signs. Linear B looked like an equation with 2 unknowns: the writing system and the language behind it. The early 20th century didn't make that easier. Sir Arthur Evans, who excavated Knossos and brought Linear B to the world, was convinced it could not be Greek. He believed it belonged to a distinct Minoan language and culture. He also published only a fraction of the material in his lifetime, which slowed progress and stifled collaboration for years. Even so, the number and behavior of the signs hinted at a syllabic script, roughly 89 signs that likely represented open syllables like ko or so. The real breakthrough, however, came from a different angle. Alice Kober approached the tablets with ruthless discipline. Instead of guessing meanings, she mapped structure. Which signs cluster? Which endings repeat? Which word shapes vary systematically? From that painstaking work, patterns emerged. She showed that the language was inflected. Words changed their endings in ways that looked grammatical. She saw evidence of gender contrasts. She identified Kober triplets groups of 3 related words that shared the same stem, but alternated their final sign, like noun or adjective forms shifting case or number. She also suspected that a frequently recurring 3-syllable word could be the name of the palace city itself. On that foundation, Michael Ventris, an architect with wartime experience in code breaking, built a phonetic grid and tested it with plausible place names. The moment he tried local geography, the pieces started to click. Ko no so matched Knossos. amini so matched amnissos, the nearby port. Even better, the adjectival forms tied to amnissos rendered on the tablets as amini sijo and amini sija behaved exactly like archaic Greek endings would. Further patterns, including expected declensional endings, fell into place. Ventris had long argued for a non-Greek solution, but the evidence forced a reversal. With classical philologist John Chadwick, he announced in 1953 that Linear B records an archaic dialect of Greek, what we now call Mycenaean Greek. The texts they could now read were not poetry or myth. They were palace records, inventories, rations, lists of tribute and allocations. They were dry, but they changed history by pushing Greek writing centuries earlier than anyone had imagined. Even without a bilingual key, the combination of data, method, and nerve was enough to crack the code. There's more detail worth noting about Koba's groundwork. She worked up card indexes and grids by hand and proved several things before anyone knew the sounds. First, the language behind Linear B was inflected endings changed in patterned ways. Second, there were gender distinctions, with related word forms diverging at the final sign. And third, certain three-word families. The Koba triplets shared a root while alternating predictably at the end, like case or number. She also suspected that a frequently repeated three-syllable form was the name of the palace city itself. When Ventris expanded her grid, he kept her structural constraints intact, not assigning values freely, but checking them against those constraints and the tablet's limited context. The matches to knossos and amnissos weren't lucky shots. They were reinforced by surrounding morphology. The adjectival forms amini sijo and amini sija behave exactly like archaic Greek adjectives would. Elsewhere, endings that function like genitives show up precisely where a genitive makes sense. And because decipherment opened a pipeline to content, we learned what those palace archives actually cared about. Cloth, oil, bronze, grain, rations issued to workers, offerings to deities, lists of tribute. Not literature, but a gold mine for historians, and a decisive proof that writing in the Aegean hadn't vanished and reappeared out of nowhere. It had a continuous bureaucratic life stretching back much further than anyone had thought. So why do some scripts remain silent? Take Linear A. We can sound out many signs by analogy with Linear B, but the language doesn't match Greek, and no consensus has emerged on what it is. In a sense, we can read the script without understanding the words, which leaves us half a step short of a true decipherment. Consider the Indus or Harappan signs. The system flourished roughly between 2600 and 1900 BCE. We have thousands of inscriptions, but most are painfully short 2, 3, 5 signs, usually on seals or pottery. Without longer texts or a bilingual, it's incredibly hard to recover a language and its grammar from fragments that brief. Computational studies can say something about order and structure, but meaning still sits behind glass. And on Rapa Nui Easter Island we find Rongorongo. It's memorable at a glance because of how it's laid out. The lines are arranged in boustrophodon fashion, each line read in the opposite direction from the one before, with the tablet turned 180 degrees between lines. It's ingenious, and it's a nightmare for comparison. Scripts, hands, and small variations multiply the possibilities. The underlying language is Polynesian, but the system itself has resisted a convincing, universal reading. Add Cypro-Minoan to the list. The corpus is tiny, the texts are very short, and the odds are against a breakthrough unless a great cache or a bilingual comes to light. In the end, the big constraint is not brilliance, it's the data. Sometimes we are missing context, sometimes we are missing length, and sometimes we may be holding a set of signs that wasn't meant to encode ordinary speech in the first place. None of this is cause for despair. Every new excavation, every improved image, every better statistical method can move the fence posts. That has happened before. In 1930, few would have predicted that anyone could show Linear B to be Greek, and yet that is exactly what happened through patience, craft, and the courage to test ideas instead of merely repeating them. So, back to the Phaistos Disc. Is it a fake? We don't know. Is it possible? Yes. Is it worth talking about? Absolutely. Science is not only a list of answers, it's the discipline of honest questions. That means resisting seductive stories, refusing to stretch beyond the evidence, and pausing when beauty dazzles us more than the data. If you enjoyed exploring puzzles that sometimes whisper and sometimes refuse to speak, stay with us. Like the video, subscribe, and tell me in the comments which script you want me to tackle next. I promise you this, it will be interesting even when the most honest answer is still, we don't know yet.